We're in Precalculus. Today is Wednesday, January 16th. Please put your name and date on your papers, 1/16.
It's not 17. I'm just kidding.
Made me look. All right, so vocabulary. Independent. What does it mean to be independent? We had our warm-up, and I guess I can just show what our warm-up looked like. Our warm-up, where we talked about independent versus dependent. What does independent mean in your own words? What do you think?
That no one busts me.
Say it again.
That I'm an independent woman.
Don't need no man. Daisy, what's your own definition of independent when it comes to probability?
Independent means you don't really have to rely on anything else but yourself.
I think you're thinking of like the real world
Oh, the
independent
real world?
definition.
Okay,
I want the math definition.
The math definition.
When two things don't go together.
Close, yeah, that's really close. When one event does not, capital not, affect the probability of the other event. And that works both ways. So if, for example, a good idea of independent activities would be me flipping a coin and rolling a die. Getting heads is not going to affect if that die comes up with a 6 or not. They're totally independent. But things that are dependent are things like the probability of it snowing and the probability of being in a car accident. You're more likely to be in a car accident when it is snowing, especially for people that don't know how to drive in the snow.
I don't.
Yeah, so all those people that come up here from LA that just crash everywhere, it's always not
It's always
fun.
fun.
All right, so review from yesterday, and or. Those two things. What does and mean? Whenever you see and, you do this operation. And means
Oh, it means probability of A plus B.
so you're saying add?
Yeah.
No, not add.
So multiply.
Multiply. Yep.
Sorry.
Multiply. Or you can do the time symbol if you want. Or. Or means add. And when you add, you have to use, we'll do a note here. What rule do we have to use? Addition rule.
Swag.
But that's where you add them both and then divide, or then you subtract by whatever the and was. All right, so let's go on to example one. We're not really doing or today. We're doing a bunch of and we'll do or later. Actually, we already did or technically yesterday, but we're just doing and a bunch of times today. So kind of eliminate or, that's just some good review. Okay, so here's my example. Oh, I just talked about this. So you flip a coin, quarter, let's say, and you roll a 6-sided die. What is the probability that you will flip a heads and roll an odd number? So what are we going to do here? We need to find the independent probability. So what's the probability that I flip a heads?
1 out of 2.
1 out of 2. What does and mean? It means multiply. So 1/2 times, what's the probability that I roll an odd number? On a 6-sided die, rolling an odd number. What is my chance of rolling an odd number? Whoa, that's a blizzard right there. It's like a freaking ice tornado. Yeah. Wow.
3 out of 6?
3 out of 6?
Maybe.
I don't know, Rochelle, what do you think? Rolling an odd. 3 out of 6, which reduces, well, we can just leave it as 3 out of 6. 3 out of 6. That reduces to 1/2. So 1/2 times 1/2 is?
Do you have the little like roller thing that you eat?
Lint roller. That reduces to 1/2. So 1/2 times 1/2 is? 1/4. There's our answer. You have a 1/4 chance of rolling the heads and rolling an odd number. Let's try another one. You flip a coin and roll a 6-sided die just like before. Now what's the probability that you flip a tails and roll at least a 10 when you add the 2 die together? The 2 dice, I should say, together. So first of all, what are we going to do? Same thing as the last one.
So it'd be 1/2.
Yep, 1/2 for the chance of rolling tails. And this word means add or subtract, multiply, divide. What am I doing? And means
You're looking at me?
looking at both of you.
Multiplication.
Multiplication, yep. 1/2 times. Roll at least a 10. At least a 10. So you have your charts.
You can't though.
At least a 10 when you add the 2 dice.
But it says die.
Oh, shoot.
Ooh!
Oh, shoot. Roll, let's change this to, and roll 2 6-sided dice. Thank you. Yeah, teacher error. Log it. I was about to give you XP, but we're not doing that anymore. Log your extra credit. All right, and roll 2 6-sided dice. So what's the chance that you roll at least 10 when you add the 2 dice together? How many are there? And if I'm thinking about this in my head, I'm thinking, okay, I can do
Wait.
a 4 and a 6, 5 and a 5. I can do a 6 and a 4. I can also do anything that's higher than that. So I can do this value,
6.
this value, and this value. So these add up to 1, 2, 3, 4, 5, 6 out of
36.
6 out of 36. So the chance of rolling at least a 10 is 6 out of 36, which reduces to
1/6.
1/6. Yep. So when I multiply these together, I get
1/12.
1/12. So you have a 1/12 chance of rolling at least a 10 with 2 dice and flipping a coin getting tails. Cool. So that's kind of cool. Easy enough. Make sure we box our answers. I talked about this yesterday. Today it's being more formal. Well, I guess it's the same formality. Just going over it again. Repeated independent event. So if I have an event and the probability of that is something, and I do that like 7 times or 10 times, when I repeat that event over and over with the same probability, what you do is you take that probability and you take that and you multiply it by the next probability. So probability times probability times probability times probability. We agree? But repeated multiplication is the same thing as what? If I say probability times itself 3 times, that's the same thing as probability to the exponent of 3. Yeah, so it's probability to the exponent of number of times. How many times did you repeat it?
Not gonna lie, that got me, that was messing me up on yesterday's homework.
Yeah, me too.
Okay, it'll definitely mess you up on today's homework if you don't know it, because I'll show you an example example 3 and 4, what happens when you use this rule. Okay, here's another thing that we can add. What's the chance that you don't do that probability? When you don't do that probability. So the probability of this not happening, let's write this down. Not happening is the following. Not happening is 1 minus the probability. Probability. All of that to the power of the repeated times.
1 minus the probability?
Yeah, so the probability, so let's say the probability of me losing my phone is 0.1. The probability of me not losing my phone is 0.9. How did I get 0.9? I did 1 minus 0.1 to get 0.9.
Oh, okay.
Daisy?
Wait, what?
So the probability of me losing my phone is 0.1. What's the probability of me not losing my phone then? It's 0.9.
Oh, okay.
You just do 1 minus whatever that probability was. And again, if you're doing this multiple times over and over again, what's the probability that I don't lose my phone 7 days in a row? 7 would be the repeated times. So repeated times. Although losing my phone having a probability of 0.1 is very, very high. I would say it's closer to maybe 0.01. A 1% chance, not a 10% chance.
You only use not happening if the probability is big?
No, it could be big, it could be small. It means it's not happening. And we'll see that in example 4. Rochelle, you're shooting free throws, and I'm going to ask for the probability of you missing instead of making the next free throws. We'll do that after example 3. I just want to play with this rule. So we're flipping a coin 6 times. What's the probability that you get tails every single time when you flip it 6 times? Well, what's the probability of just flipping tails?
1/2.
Okay, so we're going to do 1/2. That's the probability. That's this base blue number. And then how many repeated times are we doing this? 6. Do you have your calculators ready? I can do it for you if you want. 0.5 to the power of 6 is 0.015625. 0.15625, which is approximately 1.6%. So you have a 1.6% chance of flipping a coin 6 times and getting heads or tails, I guess, whatever you choose, every single time. So if you choose tails, it's that percent chance, 1.6. This is really cool. So what if it was 10? Can you flip a coin and get tails 10 times in a row? What percent chance is that? So it would be 0.5 to the power of 10. And we're going to multiply this by 100. So this is the percent chance. You have a 0.09% chance.
Isn't it 9.7%?
Well, I multiplied by 100 already. So if I don't multiply by 100, it's that decimal. That is the probability out of 1 of getting it. If I change it to a percent by moving the decimal 2 places, you get a 0.09% chance. So basically never. But if you can actually YouTube this, there are magicians that have trained themselves, which is really boring, like training yourself to flip exactly what you want every single time, and they can roll or they can flip tails 10 times in a row.
Seriously?
Yeah, you can train
You should
yourself.
watch it right now.
I don't know if I can find it right now. I know that I watched it before. I don't know if I can find it on YouTube. I watched it on like a documentary channel. Let's go to example 4. And then if we have time at the very end, we'll see if we can find that YouTube video. So Rochelle, you're up. You make your free throws 61% of the time. 61% of the time, which is good because NBA players make it like 70 to 80% of the time. You're almost NBA. You're at 61%. Yeah. All right, so making or missing your previous free throw does not affect the current probability. I say that because I need to say this is independent. Assume it's independent, okay? What's the probability of you missing your next 7 shots in a row?
0%.
0%. I will never miss all of them. Well, it's pretty it's really close to 0%, but which of these letters? Is it A, B, C, or D? Daisy, Rochelle, you're answering this one.
People have been making fun of my voice today, okay? I'm not down for you making
Yeah,
fun
Mr.
of
Chanel,
my
that's
voice.
Okay, I'm not trying to make fun of your voice.
Sorry.
Which one is it?
Um,
A, B, C, or D? Well, the chance of making it would have been 0.61.
Oh, so it's isn't it? Oh wait.
The chance of missing it is 1 minus 0.61. This is making,
oh, yeah.
Is it?
this is missing. And then I have to do that 7 times. So the answer is, you got it. C.
Got it right. On point for Daisy.
What does that equal?
Let's check. Okay, so what's 1 minus 0.61? You can do that in your head.
0.39.
0.39 to the power of 7. You have a, and then should we turn it into a percent? Times 100. So you have a 0.1% chance.
Okay, thank God.
You won't do that, yeah.
Okay, thank God.
All right, Daisy. Captain Daisy, I should call you. Captain Daisy has a ship, the USS Sokotoa.
Oh.
Okay, the ship.
Name my ship that.
Yes, you would. It's a beautiful name.
No, I wouldn't.
All right, the ship is 2 furlongs. Each furlong, by the way, is 1/8 of a mile, if you didn't know that. 1 furlong is 1/8 of a mile, so 2 furlongs is 1/4 of a mile. You're 1/4 of a mile from the dread pirate Leadness. And his... It's Sindel backwards.
Oh! What
The dread pirate Leadness and his merciless band of anti-mathers. Daisy has a 3/4 chance of hitting the pirate ship. You're going to fight. And the pirate Leadness only have half of his brain, so he hits Daisy's ship with only a probability of 1/5. Assume that both ships are firing their cannons at the same time. So they're independent probabilities because, okay, this is super important. Tomorrow's lesson is going to be talking about one shooting and then the other shooting. In this case, both are shooting at the same time. When one shoots and the other shoots, that's different because what if one shoots and then kills a ship and it goes down? Well, then you don't have the chance of shooting back, right?
Yeah.
So now they're both shooting at the same time. Therefore, it's independent. So let's underline this. At the same time, underline that. This means independent. What is the probability that they hit each other's ship? So what am I going to do with these chances? 3/4 and 1/5? Do I need to do 1 minus that at all?
No.
No, it's just that probability. Don't do 1 minus it. And then I need to do what with them? Multiply them, yep. So it's 1/5 times 3/4, which is what? 1 times 3 on the top. Shout it out. 3. Daisy, 5 times 4? 20. There it is. If I had changed the problem to what is the chance that Daisy hits but Captain Leadness misses, then I'd have to do 1 minus 1/5 times 3/4. Does that make sense? Uh-oh, not for Rochelle. So in order for, this is the probability that you hit, right? The probability that you miss would be 1 minus this. You have a 1/5 chance of hitting. That means you have a 4/5 chance of missing. Yeah? All right, that's all I'm trying to say. 1 minus 1/5 is 4/5.
So it'd be 4 or 5 times by 3 or 4.
Yeah, so that would be the chance of Leadness missing and Daisy hitting. Yeah, perfect. That's all I have for the notes today. Go ahead and do your summaries as I try to find a video. YouTube, flipping coin 10 times and getting tails each time. Let's see if someone can do it. Okay, the Khan Academy videos. Oh, 10 flips in a row. Oh, it's a number file video, which is cool, but there's a magician that I saw that was doing it. It looks like it's not on here. Oh, Darren Brown, that might be. No, is it a mathematician? There's definitely a magician out there that can do it. Okay.
Can I watch your basketball team?
Well, that concludes the notes.